Good morning or afternoon. I am putting together a video lesson today. I will be out. And so the first step is to know that we are starting a new unit, exponential and logarithmic functions. In Algebra 1, you had exponential. You've already learned about exponential functions. So we're kind of doing a review today. We're not going to get into logarithmic functions yet, but we're definitely going to make sure that everybody remembers or can review exponential functions because they're very closely related concepts. So you have to really understand exponentials to understand logarithmics. So the first thing is, as usual, I'm going to go ahead and put test examples to know, Unit 7. And the examples we're going to go over today and that are good to know are right here. Um, so those are the page numbers. So I would recommend getting a book or using the online version of the text. But I'll go ahead and go over the key things. Okay, the first thing I would do is to do a quick review of exponential functions and what's involved with evaluating one with a calculator, or you should be able to do it with smaller numbers just by hand as well. But if you're going to use a calculator, for example, you get a decimal or something like that, and you have a function like 2 to the power of x, these are the calculator steps that you could try. So you may want to try that with both, and especially this fraction right there, because a lot of times students aren't quite sure how to do it, but it tells you you should use the parentheses for the exponent when you have a fraction like that. And the negative, make sure you use the negative sign. But anyway, I would try those just to make sure that you remember how to use the calculator for that. So take a moment to do that. When you're done with that, so you may want to pause this, but when you're done with that, this is a really good review here of being able to understand, based upon these exponential functions, what does the graph look like? So what you might want to do is just pause the video for a moment and see if you can figure out, based upon, either making a graph or and by the way, when it comes to making a graph, you may want to try it both ways. One with the graphing calculator, and one with a and if you don't know how to do that, we'll do that in class. But for today, maybe what you can do is just make a quick table of basic values and then see if you can match it up. So take a moment to do that and come back and I'll kind of explain how you might have been able to tell what they are. Okay, the first key thing you'll notice about it is graphs either start from the left and go up, like these three here, or they start from up here and they go down, downward sloping. And the way to figure that out is to look at the base. The base is the number that's being raised to the variable x. If you notice, the base is something like 2 or 1/2 or 3 or 1/3. Basically, A, B, and C all have numbers greater than 1 as the base, and down here less than 1. So basically, when the base is greater than 1, you're going to have an upward sloping exponential function. It's called growth. Or if it's a fraction less than 1, like these three, it's going to go down. It's called decay. So that's one way you can distinguish between the graphs. The other one is looking at the number, the coefficient that's being multiplied by the base that's in front of it. So for example, 2, there's no number in front of it. Okay, so in this case, basically there's no number, and I'm going to show you the general function, but there's no number in front of any of these bases. What that means is, technically speaking, the number, the coefficient would be 1. And whatever the coefficient is, that's going to be the y-intercept. So in this case, like I said, they don't have anything that's shown, so it implies that it's 1. And if you look at every single one of these, the y-intercept is 1 on every single one. We're going to talk about when that's different and what it looks like in the graph. But for now, the very important thing you understand is either the base is greater than 1 and it's upward sloping, or the base is less than 1 and it's downward sloping. Now, to figure out to distinguish between, when you, like for example, A, B, and C are all greater than 1, so they're going to be upward sloping. Well, how do you determine which one's 2x? Well, what you can do is you can look at, for example, when you're looking at A, for example, when you go from the first value at the y-intercept and you go to where x is 1, it goes up from a y value of 1 to a y value of 2, right? that means you're doubling it. So that's going to be A. So B, on the other hand, let's see. It starts at 1 and it goes through at 4. So the y value when x is 0 is 1. The y value when x is 1 is 4. That is basically multiplying by 4. So that's going to be the 4x. Okay. The fractions are the same. It's just going to be divided. So here, plugging stuff in is helpful. Actually, it's helpful on the ones that are fractions to maybe even go in reverse, right? So here you've got at -1, it's 3. When x is 0, it's 1. That means 3 going to 1, it's being divided by 3. That's 1/3. Okay, so that's how you can kind of tell what the growth factor is, or the decay factor is, when it's downward sloping or decaying. Okay, so what next? Okay, so next thing we're going to do is we're going to start looking at some things that are involved in understanding exponential growth and decay functions. Again, this should be a review from Algebra 1, but you definitely want to go through it and read through it. A few key things that I want to make sure you understand is that the general exponential function, the form of it, is y equals a times b to the power of x. A can never be 0. B is always the base raised to the power of x. And basically, if a is greater than 0, or a has to be greater than 0, and b is greater than 1, then it's an exponential function, exponential growth function. We talked about that earlier. The ones that are upward sloping have b's that are greater than 1, and b would be called a growth factor. Okay. And I think that page that we looked at had the simplest type of exponential function. It didn't have an a in front of it, which kind of technically means that it does have an a. It's just that the a is 1, and therefore we don't need to show it. Okay. Okay, so parent functions for exponential growth functions. Again, this is your parent function. B's got to be greater than 1 for exponential growth functions. Okay. And this again is the general shape. And the key thing to notice that I was looking at earlier was that when you're at the y-intercept where x is 0, and in this case the parent function is 1, the way to tell the growth factor is to see how it increases when you go from an x of 0 to an x of 1. What happens to the y value? Well, it goes from 1 to b by multiplication. So if b, for example, was 3, then you would multiply the first y of 1 times 3, and it would make the next b 3. Okay. Now, the next thing is what happens when b is a fraction between 0 and 1. That's called an exponential decay function, and b would then be called the decay factor. Same thing here. The only difference is, a fraction would determine what you multiply 1 by to get to b. So if b was 1/2, you would take 1, the first y, times 1/2 to get a value of b. Okay. Now, asymptotes. We're going to talk about asymptotes. Okay, the asymptote of a parent function is just going to be the x-axis. Same for a decay function. That's the parent function. But we'll talk about later translations, what happens when the graph is translated up or down, etc. What happens then? Okay, so I've already, looks like I'm 9 minutes into this graph, into this video. So I don't have a lot of time. I've got 15 minutes maximum for this video, so that YouTube accepts it, I think, or at least this program does. So I've got 4 examples that I really want you guys to focus on as you go through it here. The first one is being able to know when a function is growth or decay. I already talked about it, so I'll let you guys go through the steps, and it tells you how to figure it out, but I think you probably already have an idea of how to figure out whether it's growth or decay. But please go through the steps and just read through it and see what questions you have. If you want to test it, remember, if you're in the ebook, you can click on these and that'll go through and explain it. There is something that's really important to think about here that I want to spend some time with, and it's exponential growth models. So please read this here really quickly. That talks about how things increase or decrease. Now, you'll see a different version of the exponential function. Instead of it being a times b to the power of x or some variable, it splits it up between 1 plus r or 1 minus r if it's decay, okay? And that r would represent the percent as a decimal. So for example, if it was a percent increase of 20%, you would have to take 20 and divide it by 100 to turn it into a decimal. So this inside this parentheses, you would have 1 plus 0.2, or 1.2 would be your b when you combine those two together. If it's a 20% decrease, you divide the 20 by 100 and it'd be 1 minus 0.2, which would be 0.8. So your b would be 0.8. So that is a very important, you may want to take notes on that. That's how you convert between seeing what the rate is of the growth in percent terms, or just having b, just having it, like for example, a coefficient like 4 or 0.25. When it's written like this, you can see what the actual rate is. But you would add them up to convert it into the b factor that we see in the regular formula. Okay, so let's see. Real life problems. This one here, I think number 2 is worth going over. What it does is it gives you a real life situation where you have an a value, a b value, and a variable there. So you want to kind of read through it and try to think about what you think it is and then read the explanation. But what's really good about this one here is they take the base, the b factor, and they calculate what the percent increase or decrease is based upon that. So try to figure it out a little bit based upon the formula in the previous page, and then come back and look at the explanation. This will be very important to learn. I wish I was there today, but that's very important to learn, and you'll have some examples about that. Okay, the next thing is example number 3 goes over how would you write an exponential model if you had some beginning value. Remember, a is the beginning value, and you have a percent increase, it looks like, yes, percent increase and a certain time. What would it look like if you were going to write it? So it goes through the solutions there, so please go ahead and go through it. Again, a is the beginning value, so that's a 6.09. You have to convert the percent into a rate, so you have to divide by 100. That's why we got this value here. If you're wondering why isn't this 1.18, you have to divide by 100, and then t would just be the variable, okay? And then you can use your calculator to figure out what the value would be after 5 years. Is it 5 years? Why did they put the 5? Yeah, so it says T5. All right, so that's how you did it. Here's some other examples. If you want another example that's worked out, please go over those. Rewriting an exponential function. That would be the last one that you want to go over. And this is a situation where you have a radioactive isotope. If you've had science, you may have already learned that radioactive isotopes decay and they have a half-life. So that means the half-life is there's half left over after a certain period. And that's why this is 0.5. You could also express it as a fraction. Again, A is the initial amount, and they're asking what the percent is that decays each day. Now we know that 50% decays each day, but we want to know what it is daily, or sorry, 0.5 would be like an annual rate, but we want to know what it is daily. So it goes through this and it breaks it down into the daily thing by using the power property. Okay, so basically what it's doing is it's breaking up the t over 28 into t times 1 over 28, which then applies to the 0.5. Okay, so you would take 0.5 to the power of 1 over 28 and you would get this. And then now that you have your b, you're able to turn it into this situation over here and write it in that form to be able to figure out that's this rate, which you would multiply by 100 to get the percent. Okay, we're going to skip compound interest for a moment, but at this point, my video is about to go. I think we're done for the day. Now you're ready with these 4 examples to do the homework assignment, and we will review tomorrow.